Now, let us look at um, the last part of the chapter, data measurements. So we see that previously we see that we can organize the data in a table. We can visualize data by using different graphs. But for finally, it's also a very important task is that we need to provide some way to summarize the data by um, different quantitative measurements. So there are three main measurements we use to assess data are center measurement, variation, and then a relative standing point and standing position. So as a center, it helps us to learn about the central tendency of the data, like the mean, the median, mid-range, and mode here. So we see all these concepts in the next couple of slides. For variation, it shows the fluctuate of the nature of the data. And then this is the heart of the uncertainty word, right? And then this makes the thing interesting and make statistics and probability stand out compared to other field of math like calculus, algebra. So we look at the range, the variance, and the standard deviation. For relative standing position, basically here it just gives us the idea where each data point stands in the bulk of the data set. And we look at z-score and quantiles. And here there's one terminology we call resistance. Okay, so resistance, which is basically like a measurement we call resistance if it does not affect much if there are outliers in the data. Yeah. So say if you add one extreme value in the data set, and your measurement will call resistance if that only add-on does not affect the whole bulk of data. So first, we look at center measurements, and the mean is the most important, pretty much the first thing, right? You think about, right? Basically, like what we do is we just add up all the value, we divide by the total. So fair enough, right? And the notation here is x and bar, right? X bar. So this is a notation we use to represent the mean. I just add up everything and divide by the total, right? So if you just see you have three tests, right? You score 81, 83, 85, and you can get the mean easily, right? So add up, divide by 3, and you get the average, right? The mean. It helps to understand the center of the data. And the good thing is that, everyone contribute, right? But the bad news is that it's not resistant, okay? So for example, say, you have like two tests is 90 and 100, right? But one test in kind of, because before a test day, right, you were sick by different reason, you got 0, right? So basically that outlier will make things, become look worse, right, for your case study, right? Because if you add up 3 and you divide by 3, all 3 tests, right, and you divide by 3, and it won't tell much about your true ability, right? So this is called not resistant. You can think of, maybe the income of people in this county, right? In Hamilton County. Let's say, one day a billionaire like Bill Gates, he moved here, right? And if you add him on and you divide by all the people, and I believe the income here will shift to maybe $1 million a year easily, in which he is not represent well the true income, right, of people here. We do have modified version called weighted mean, frequency distribution mean. So the weighted mean basically, like here in this case, each data point has its own important, right? And basically, what you do is that you just use the value, you time with the weight, and divide by total weight. So here, like in this example, we look at the course assessment, right? And so the course assessment score here for a class, we have participation is 0.1. Okay, so the pie chart here tells us. Okay, the quiz here 0.2, 20%, homework and 10%, project at 10%, and test you have 50%. Okay, so for example, like this person, she has a participation is 100, the quiz 85, homework 95. Okay, project is 100, and test is 90, right? So then you can get the final score easily by using participation times the weight plus the quiz times the weight here, homework times the weight, project times the weight, and test times the weight, right? And then divide by total. So in this case, the total 100% and 1, right? So in this case, you got a 91.5, and yeah. And you say if you have cut off greater than 89.5 and A, so this person will get an A. For the frequency distribution mean, which is, we can calculate the mean for the frequency distribution, right? Which is a modified version of the mean. So here, like if your data is given by a table, right? Frequency table, and then you can also get the mean for that table by using this formula, x1 times w1 plus x2 times w2 to xn times wn, and divided by the total weight. So here, like the xi will be the class midpoint. Okay, so for each class you have a number represent for each class, right? Which is the class midpoint. So for example, this class, well, yeah, the midpoint 0.99 divided by 2, right? You get 4.95. For this class, you have 14.95. This class, you got 24.95. This class, the represent number would be 34.95, right? And then you time the frequency. So this guy, you have 7, right? This guy, you have 13. This guy, you have 8. And this guy, you have 2. And you divide by the total, which is 13, right? So you can also get mean for this length of the linear big for the data set. Another important measurement, which is very important, is um, another important central measurement is a median. Okay, so the median basically like it help to show the middle value in a sorted list of data values. So you can sort the data either in the ascending order or the descending order. Okay, and then the median just the middle value, and you already know by the x zero, and sometimes people already know by the m med for median, right? MED, a P50, which is 50 percentile value. And we will see this concept very soon. There are no explicit formula for finding that, but basically like the way we find also easy. We just sort values on order or ascending or descending. Okay, and then for odd sample, which is a sample with the sample size odd number, so it's just exact middle value. For sample size even, okay, and then we just use the two middle of the sorted list and divide by 2, right? Just the average of them. So the pros is that if you're very resistant to the outliers, in the case you have one extreme value show up in the both data, the median won't be affected. But the cons here is that it doesn't have an explicit formula like the mean, right? And you also should be able to know that basically here they don't consider the value of each data point too much, right? But they just look at the ranking of each data point. So let's look at an example, okay? So you see like why mean or median should be used, right? So in this case, we have the annual wage of a 5-member at a region bank at 300K per year to 200K per year, right? 230K, which is 230,000, 178,000, 103,000, and 142,000. So for mean and median salary of the group. So for the mean, you just add up, right? So we look at the answer part by part, okay? The example part by part. For the part A, right? The mean is easy, right? Just 200 plus 230 plus 178 plus 193 plus 112, and you divide by 5, right? And you get the mean here. The median, in this case, you have a sample. The first thing you need to do, you need to rank it, right? Either descending or ascending. So let's look at ascending, okay? 142, 178, right? 193, 200, and 230. And then because we have an odd sample, right? 1, 2, 3, 4, 5. So the middle value is the median, okay? So in part B, then John Turner, okay, region bank CEO, okay. He has an annual wage of 13.5 million. Now add it to the group, okay, find the median wage in the group. So you can see that if we add him on, now we have 6 people, right? And you add up and you divide by 6, right? And you can see like the income here become 2,040K, which is about more than 2 million, right? 2 million, the average for each person. So if we use this number to represent for the whole group, it won't be fair for these people, right? Say if you use this and just check the tax this person like this, right? In this group, and then these people will be in miserable situation, right? um, so in this case, the median will be a powerful measurement to show central tendency, because after you add the CO in, and you also order by ascending order, and in this case you have an even sample, right? So you have two numbers in the middle, 139, 193, and 200, right? And the median was just the average here, so you got like 196.5. So from now on, you should be able to know that, like, if you just look at the mean alone, it's not enough, right? Typically, people look at the mean and the median together, okay, and to see the central tendency of the data. And in some sense, the median is even more important, right? More important if you have to choose one number, right? Because it's very resistant to the outlier. We have a mid-range, which is just use the max plus a mean by 2. So it's a quick way of scanning the data. It's much faster, right, in terms of computation compared to the mean. Because the mean, you need to look at all the value and you divide by the total, right, number value, right? But here you just look at 2, max, mean, and divide by 2. The mode is the data value that we greatest frequency, okay? So for a data set, it can have one mode, no mode, or multiple modes. So furthermore, here, like we look at the age of a 10 Blue Cross insurance customer, we have this ages, right? You can quickly calculate the mid-range by using the max plus the mean divided by 2, right? And the mode, which is the number with highest frequency, which is 78 here. Basically, like the mode tell you like where it most occur, right? Most occur. So here, like the relationship between the mean, median, and mode in data distribution. So for symmetric data, they all kind of pretty much at the center, right? So they all equal. For left skew, often we have like the nature, which is the mean will be much less than the median and less than the mode, Okay, so this is what happened with the left skew data, and because the most of the data will concentrate, right? Concentrate on the right side, right? For the left skew data, some will gonna stay on the left side. So this way, it pulls the mean here, right? Here, pull the mean here. And then the median will be in the middle, right? Middle, because it's kind of resistant. It pulls them together in the middle here. So the mean obviously is less than the median, right? And because you have some very small value, you need to start the results, right? And for right skew data, because most of the data will at the left, right? Left. Some will be at the right. So this makes the mode also stay on the at the first place, right? Smallest value. And then the mean, which is because it was posed by some extreme value, right? Extreme large. Say we talk about, you see the region bank example, right? So the CO will just post everything up here. And the median is kind of resistant. It just still kept in the middle here, right? So this is the relationship between the, these three value, mean, median, and mode. for different case of data distribution. So now let us move on to the variation measurements. This is the heart of the uncertainty board, and I think it's the most important thing. And it really makes statistics and probability stand out in the mathematics world. And if you look at the things around it, right, all are uncertainty, right? You see, the weather, right, today and tomorrow is different, right? And maybe even our characteristics, right? Maybe our attitude on a certain thing, right? Maybe today you have you don't like it, but tomorrow you start to like it, something like that, right? So here we have common measurements, and we have a range, variance, and a standard deviation. And it helps us to understand the uncertainty nature of different reward problems. And from that, it helps us to build prediction, to have a strategy, right, to minimize the risk, right? So this is what why we need to learn uncertainty, right? And this is why it makes this course become very important course and require for a lot of different measures. So here, let us look at the example about the return from three different fund. Okay, so if I imagine, okay, you got $100,000 and you want to use that money to invest, right? And you want to one kind of investment is that stocks, right? You want to do some investment, you put in some stocks, and say you want to put your money in some fund. Let's say, right? And there are three funds. Often you pay a certain fee, right, per year, but they will do the job for you, so you don't have to think about what kind of stock you need to pick, right? They're professional, right? So there are three funds, and here are the records they got. For the flash fund, which is the first fund, right? In 2020, they return 70%. 2021 return 30%. 2022, unfortunate, it become negative 70%. In 2023, it become negative 50%, and 24 is 50%. And so on. You have total fund. They don't have that much two-digit thing, but for a 5, 6, 7% for each year. And the rocket guy with 100% for the first year. So pretty much you double your money, right? And then negative 80 for second year, and then 90, negative 70, and 85. And then we can also look at the mean, right? What the average return, right? So for the flash fund is 6% for 5 years period. The total is 6%, and the rocket is 25%. So think about that, and then see, if you have $100,000, where you want to put your money on, which fund, flash, turtle, or rocket? So, if you choose your rocket, congratulations, you lose most of your money. If you choose flash, you lose money, and if you choose turtle, you'll be the winner. So look at why. Okay, look why. Let us look at this code, and we see what happening, right? So here I prepare a code here. So for return, right? Here for the flash, 70, 30, negative 70, negative 50, and 50. Okay. Right. Everything the same here, right? And then we do have a return 2 for the turtle, right? For a 5, 6, 7, and then 3 for the rockets, right? 100, negative 80, 90, -70 and 85, right? So everything correct here. So let's see, okay, let me show you. So you got a saving amount of $100,000. Okay. And say if you did invest in a flash fund, right, which you choose the first one. So after 5 years, right, what you got is $49,000. If you choose a turtle, right, turtle, let's see, after 5 years, you got $133,000, and see, you give them, pay them some kind of money for them to manage your money, right? Some fee, right? And you still make quite about $30,000 or something. So that's good. The first case you lose money, right? You only get back about. You don't want to do this kind of investment, right? You better just leave your money in your bank account, right? And for the rocket team, only for 2,000, like for 2,000 after 5 years. So even less than this flash fund. So what happened in here? Here the higher average, right? In terms of return, but they give you the less money compared to other fund. Right? Here you go quick to 200,000, but then he also done very quick, right? In 2000, then for two. So what happened in here that you can see that if you look at the first guy, the mean is 6, right? But then the variance is about 3,880. The second guy, which is a turtle, he had very low variance. And look at the third guy, which he has mean high, right? 25. The variance much higher than the other two guys. So basically, like if you just look at the mean, the moral of the story is that you look at the mean and you make the decision. And sometimes you put a lot of time to put yourself in a very bad situation. So this is what we call flaw of averages. Yeah, by Stephen, very famous biologist of the US. So he said that our culture encodes a strong bias, either to neglect or ignore variation. We tend to focus instead on a measure of central tendency, and as a result, we make some terrible mistake, often with considerable practical import, right? So this is why we need to learn the variation, right? When you need to study that, just don't look at the mean, okay, and make the decision, right? So now, just look at some way we can use to measure the variation. So the range is the distance of max and min, okay? Formula just use max subtract min. Pretty much like a mid-range, right? Mid-range you do the average, and here you do max subtract min. And this one is the example, right? Number of goals message score for his club in the last 8 seasons, like this. You can get the range, right? 57 subtract 40. So the pros is easy to compute, just need 2 numbers, but it's not resistant for sure, right? Because if you have an outlier, then pretty much you destroy the range, right? Meaning, right? And then the variance, okay? So variance is the average square distance of data values and the mean. So this is how we define variance. So say you get the mean of the data, you find distance, each value to the mean, but you want to do square, right? To avoid the cancel out, okay, phenomenon. And then you add up all of them, you divide by total, you get something you call variance. In this version, we call it population variance, okay? The another version, mostly we use in this course is a sample variance, where you divide by the n-1. And in your TI calculator, it's shown by SX, right? So most of the time you use XX. You don't use the sigma X, because the nature of statistics eventually you use in the later chapter, right? And nature of statistics is that you use a sample, right, to try to build the inference for a population. And then the reason why we use MS1 is, but not ends, and there's some mathematics behind that. Okay, and then we don't want to discuss too much in this class because you know the scope for this class. Okay, so for the population variance, we know by sigma square here, and the S square for sample variance. Okay, sample variance. So let's look at how we can calculate the variance, right? So for example, here, the SAT score for random chosen UTC freshman, right? Or this much, 100, 980, 670, 100, and 500, right? So to get the variance, first you get the mean, X bar 950, and then because here is sample, right? So we talk about sample variance, and just use each value, subtract to the mean, and square, and then add them up and divide by the n-1, which is used in this version. Okay, this version. And this is the sample variance you got. Okay. And the good news that yeah, TI calculator can do that job for you very fast, right? Let me show you how we use the TI to get the variance here, right? 1,280, right? So let's see. So you first do start here. You to edit, which is the first option here. So you got the list for the TI 980. Six seventy 400, 670, 1,400. And the last value will be 500, right? 500. So after you get all your data here, you go to start again. And you go to count here. And you want variance start, right? Choose it. This you want L1 and calculate. So it tells you the mean is 950. The SX is the one you want, right? 369.726 729, right? 29. If you round up 3 will be 330, right? But you want S square, right? So basically your S square, the sample variance in this case will be 369. Oh. Sorry, I forgot what is. Let me just double check this guy, right? So, okay. So 369.73, right? So we will 369.73, 369.73 square, right? Square gives you the sample variance. So 136,700. Is that correct? We miss a zero here. Zero here. Okay. For variance, like the inside we can gain when we look at the variance. When we have a large variance, which means your data more variability, you have more variability in your data. A variance zero means all data value will be the same, right? Because the nature of variance is that you add up this value, right? The square, right? So if the variance zero, which means each of them zero, in which means all data will be equal to the mean, right? They just have fixed case. And but the problem with variance, if you just use it, is that the unit, it will be meaningless. Okay, minutes. It doesn't have any meaning most of the time. So for example, like we talk about hours wage of people, right? So people have wage has for $10 per hour, 12, 25, $7 per hour in the neighborhood, right? For people, right? So if you calculate the variance, basically like you use each value, right? You subtract the mean and you do square, right? So it will bring up the value wage per hour, right? Dollar per hour, right? Subtract the dollar per hour, which is average, and you square, you got something called dollar per hour square. And the dollar per hour square, it just doesn't tell you anything, right? It doesn't have any meaning. And in fact, for this data, right, if you calculate, you get about 63. So basically, because of that, right, people think, okay, why don't I just do a little bit further by just take a square root, right, and bring back a unit to the normal one. So dollar per hour will be dollar square will be bring it if you do square root, right. It doesn't affect things, but it's the good thing is that it gives you the meaningful unit, right? So here in this case, instead of using sigma square, right, you use sigma for population standard deviation. So previously you have sigma square for variance, population variance, right? So now sigma we use it to stand for population standard deviation. And instead of using S square for sample variance, right? Now you use S for sample standard deviation. And everything the same, just do square root, right? So the formula, you can see that now we take a square root, okay? So now we revisit this example, right? So our wage for randomly chosen residents in neighborhood, right? And you can calculate the mean, then you get the sample variance here. And then because the unit here, mean is right, you take a square root and you bring back to dollar per hour. And again, and here is how you just use the, you can use the TI, right, to get the mean and the standard deviation. So I would recommend that, when you first study, right, this measurement, you can use the, TI to calculate manually. But eventually, when you get used to with the concept, just use this procedure to get your mean, your variance, because it will help you to avoid some, a lot of mistake, right? A lot of mistake. So you can see, like in this example, we just, also make a mistake here, right? So here, look at this quiz. We want to compare the efficiency in terms of, electric bills, right? By central air and window air conditioner. So we look at look at the bill, right? Electric bill, right? For a family who use central air, maybe in another family with the same size, right? And use the window air. So here's the bill for each family. So the question is that find the mean and the standard deviation for each sample, and then we try to look at which cooling system would you choose, right? Based on the data. So in order to compare, right, often we first look at the mean, and then we also look at the standard deviation, right? So which is the first part of this quiz. So let us just use the TI calculator to obtain the value for each of them, right? The central and the window. So now we have start here, edit here. We can clean the column here. Okay, so nothing left here. So first L1 for central air, 3664, 3664, 36, 64, 80, 90, 67, 80, 90, 80, 90, 67. So this is the bill for central air, okay? 36, 64, 80, 90, 67. For window air, we have 15, 74, 84, 15, 74, 84. And then 130, 36, 130, 36, okay. Let's do one more sanitize check to make sure we all have all the value correct. 15, 74, 84, 130, 36, 36, 64, 80, 90, 67. Okay, all sound good, right? All good, all good. So now we do the start here. We do edit again. Oh, I'm sorry, start. We will count here. So let's do for L1, the central air, right? What will it give us? The mean is 67.54 and the sample is standard deviation is 20.416, right? 67.4. So central here 60. Put X1 here. Oh, the S1 is how much here? 20.415. 20.415. Right? Round up, right? 416. If you keep 3, it will be 416, right? And for the window air, we call X2, okay? S2. So window air we do, let's see, window air. So you start here, L2, right? Second 2. 67.8 and 44.634. 67.8, 40, what? 44.634. So you can see from here, you can see that for window air, it has a higher mean, right? Higher mean in terms for the bill, right? It also has higher standard deviation. So for sure, we will go with central air, right? Central air. It had a lower mean, it had a lower standard deviation, which is more stable, right? More stable. It had low mean, right? And a lot of time, people also see, even, you have a slightly higher mean, but you have much lower standard deviation. We also go with that, right? So you can see in the rocket return example, right? So this is why we need to look at the uncertainty, right? Uncertainty here. Because we want basically things under control, right? We don't want to end up a situation like, where some months you pay nothing and some months, you just pay extremely high amount and it your credit card, right? Too much, right? So now let's look at the empirical rule for bell-shaped data. So bell-shaped data are the normal data. We have a very important rule we call empirical rule, which tell us like even I don't need to look at the whole data chunk, all the raw data value, but I know that for bell-shaped data, 68% of my data will fall within one standard deviation of the mean. 68, okay. Mu subtract 1 sigma to mu plus 1 sigma. About 95% of my data will fall within 2 standard deviation of the mean. About 99.7.3 of my data will fall within 3 standard deviation of the mean. So pretty much like, below mu 3 sigma and above mu 3 sigma, I got everything, right? I got everything. 99.7 of my data. Percent of my data. So let us look at an example here for the SAT score, right? It has a bell-shaped distribution. And here the mean 1,028 and standard deviation is 300. Okay, so what the percentage of SAT score between 128 and 1,928? So basically from this you can see that 128 is actually the value 3 standard deviation below the mean. Okay, the mean here. And 1928 is the value as 3 standard deviation above the mean, okay? So with the empirical rule, right, we can see that 99.7% of data will fall in this range, right? So you can conclude that 99.7% of the SAT score between these two values. So here is, let's look at this quiz, okay? If human body temperature are normally distributed, okay, so we assume that the human body temperature are normally distributed with a mean at 98.2 and a standard deviation of 0.62, okay? So the task here is use the empirical rule to determine approximately what percent of humans have body temperature between 96.96 and 99.44. So again, we need to use the empirical rule. So our job is that we need to see how many standard deviation this guy below the mean, right? And how many standard deviation this guy be above the mean. And if we can find out this thing, right? And we can see how many percent, right? So think about it a little bit and we can do it together. So this value, right, and this value, right? So for the 96.96, if you compare to the mean, right, you can see how many standard deviation is far from the mean. By just simply doing 96.96, right? And you subtract the mean, you see how far from the mean, right? How many standard deviation is far from the mean, right? And you divide by the standard deviation, right? So if you do this calculation, okay, it will tell us how far this guy from the mean value, okay, in terms of standard deviation. How many standard deviation from this guy to the mean value. And if you do the calculation, I believe you get -2. We can check it, right? We check it here. 96.96. 196. Subtract 98.2, right? Equal and divide by 0.62, right? You get -2. And the same thing, right? You want to see how far this guy from the mean, which is 99.44. And you subtract the mean, right? And far in terms of the how many standard deviation, right? And you do the same calculation, you get a 2. So basically these two value, one value, 2 standard deviation below the mean, one value, 2 standard deviation above the mean. So which means the second rule here, right? 95% fall within 2 standard deviation of the mean. So which is the answer for this quiz will be 95%.